Hello everyone. This is a sixth video on inferential statistics. Now in this video, we discuss critical region and p-value. In particular, we understand to find acceptance region, critical region when level of significance is fixed, and also we see how to find this p-value and how to identify test statistics and to find test statistic value and how to make decision when we have these two values. A pre-selection of a significance level in critical region. Now, we learned in the previous sessions that in hypothesis testing, it is important to take care of type 1 and type 2 errors. We can control the maximum risk of making type 1 error by pre-selecting a significance level. A significance level is nothing but probability of type 1 error. If alpha is a probability of type 1 error, that is, if we fix alpha is a level of significance, then 1 minus alpha percentage confidence interval for the parameter mu or P constitute acceptance region for the null hypothesis mu is equal to mu naught or P is equal to P naught. Okay, let me take an example so that you can understand these two statements in clear. For example, now if I consider null hypothesis to be equal to this mu is equal to 50 and alternate hypothesis mu is not equal to 50. And let sample mean be a 48.5 in first case, and second case sample mean be a 49. Okay, sample being 49, and sample size n be 16. Assume that population is normally distributed, and population standard deviation be a 2.5. Now look at this. When population is normally distributed, then the random variable x bar is approximately assumes normal distribution. Thus, the random variable z, whatever we find it, it's normal random variable, and the corresponding test here is called z test. Okay, and when x bar is equal to 48.5 and corresponding z value is given by this, let me call this z naught, and z naught is equal to 48.5 minus population mean. They are claiming that mu is equal to 50. Let me substitute 50 here, divided by sigma divided by root n, 2.5 divided by root 16. And this value is minus 2.4. And in second points given that, okay, now I fix alpha. Let alpha is equal to 0.05. If alpha is 0.05, then acceptance region is 95% confidence interval for this parameter mu, right? And 95% confidence interval is given by this if alpha is 0.05. Let me draw the picture of this. If this is z alpha by 2, that is 0.025, and this value is 1.96. Okay, this is equal to 1.96, and this is minus z 0.025, and its value is minus 1.96. Okay, and this is acceptance region. When z lie between this minus 1.96 and 1.96, we don't reject the null hypothesis, otherwise we reject the null hypothesis. Now in this case, test statistic value, and this is called test statistic value, is minus 2.4. Minus 2.4 is somewhere here, and this is in a critical region or rejection region. Thus, we reject this null hypothesis. This is how we draw conclusion once we have this test statistic. We check whether it is in the confidence interval or not. Now, in this case, it is not in the confidence interval. We reject the null hypothesis. Okay, we consider second case. In this case, we reject null hypothesis. That's the conclusion. Reject H naught. Second case, Z naught is what? 49 minus 50 divided by 2.5 upon root 16. This is equal to minus 4 upon 2.5, which is minus 1.6. And minus 1.6, where it lies. Okay, is this less than minus 1.96 or greater than? It is greater than, it lies somewhere here. This is minus 1.96, okay, 1.6. Minus 1.6 lies within the confidence interval, or I can say it's in the acceptance region. If x bar is equal to 49, we don't reject null hypothesis. That is, we don't have enough evidence to say that we need to reject null hypothesis. Reject H dot. This is the conclusion. That is, once we have this test statistic, we can draw the conclusion. We can say whether we reject the null hypothesis or we do not reject the null hypothesis. Next is a p-value. A p-value is the smallest level of significance that would lead to rejection of the null hypothesis with the given data. Now, what do you mean by this? Why it is required? Look at this. When we fix this level of significance, it is nice, but it is inadequate to conclude whether the computed value of test statistic is just barely in the region or whether is very far into the region. Now, once we have this p-value, as soon as you see the number, you can directly say that it has to be rejected. That is, null hypothesis has to be rejected, or it has to be means it should not be rejected. Okay, look at this. In this particular example, we got the test statistic as 2.4. If I have this as a test statistic, what we do here is we find the probability that z is lesser than or equal to minus 2.4 and multiply by 2. That is this area, which is shaded in yellow. This is 2.4. Okay, assume that this point is 2.4. And this area is called a p-value. Because once we find this p-value, we can easily check whether it is 0.05, greater than 0.05, or significantly lesser than 0.05. If it is very, very lesser than 0.05, then we can say that we cannot reject this. Okay, we can say that we reject this null hypothesis. If it is close to 0.05 or greater than 0.05, we don't reject this null hypothesis. You got this, right? This is a p-value. Now, in this case, p-value is this area. If I draw the picture, okay, I take some other color. This is 1 minus 1.6 is 1.6. P-value is the area shaded in pink when z naught is equal to minus 1.6. Okay, hope you understood this. Next, we consider different cases and we see how to write this, how to identify this test statistic and how to find this test statistical value and how to make decision. Okay, testing hypothesis on mean when variance is known. Okay, we use a z-test. In this case, we assume that n is greater than 40. That's not necessary, or population is normally distributed. Suppose null hypothesis is this, mu is equal to mu naught. In this case, test statistic is z, which is x bar minus mu divided by s, or not s in this case, sigma is already known, sigma divided by root n. Okay, and test statistical value is z naught is equal to x bar. X bar is the mean of given sample minus mu naught in this case, because mu value is mu naught, divided by sigma divided by root n. Okay, this is the statistical value. Now, once we have this, and also it depends on alternate hypothesis, we have three different cases, alternate hypothesis. Now, this can be this, mu is not equal to mu naught, mu less than mu naught, or mu greater than mu naught. If mu is not equal to mu naught, And we know that we have two different tests for alternate hypothesis. If this is not equal to mu naught, we use two-tailed test, otherwise we use one-tailed test. This is a two-tailed test. This is one-tailed. Now we use one-tailed for this one, for this case, and one-tailed for this case as well. Okay, now since this is a Z test, assume that alpha is level of significance. Alpha is level of significance. Okay, and confidence interval will be 100, 1 minus alpha percentage, which is acceptance region, and that lie between these 2 points, Z minus Z alpha by 2, Z alpha by 2. This is acceptance region. Okay, apart from that, whatever we have, this is a critical region or rejection region. And these 2 points, these 2 values are called critical values. Remember that. Okay. Suppose Z naught, whatever we found it, lies here. We don't reject null hypothesis. If it is here, or here, we reject null hypothesis. Okay. And what will be the p-value? P-value is this. If Z naught, for instance, if this is here, this is Z naught, and p-value is this area plus this area. As we can say that p-value is 2 times, this is minus Z, right? Phi of minus Z in this case, right? This area into 2, that gives this area plus this area. Okay, in one-tailed test, this mu is less than mu naught. That is, we reject the null hypothesis if sample mean is significantly lesser than mu naught, something like that. And the critical value is Z alpha, minus Z alpha in this case. This is minus Z alpha. And we reject it if Z value lies in this region, otherwise we don't reject it. For instance, if Z value, whatever we find, if it is this, then P value is this area, and P value is phi of, okay, this is Z naught, okay, phi of Z naught, this is P value. And next is mu greater than mu naught. It is, we reject this null hypothesis when sample mean is significantly larger than mu naught. In this case, critical value is Z alpha, if alpha is level of significance, because the area okay, covered by this region is alpha, and this is a critical region. Okay. And this, if this value is Z naught, and this area is P value, and P value is 1 minus phi of Z naught, right? That is P value. And we, in this case, if Z is lying here, we reject this null hypothesis. If Z is somewhere here, we don't reject the null hypothesis. Okay, that's it. We go to next case. Next case is when sigma square is unknown. If sigma square is unknown and we use Z test when n is sufficiently large, assume that n is greater than or equal to 40. If null hypothesis is mu is equal to mu naught again, and test statistic is this, Z is equal to x bar minus mu divided by s upon root n, and test statistical value is evaluated if we have sample mean, which is equal to x bar minus mu divided by sigma is not known. We have to find standard deviation from the sample, s divided by root n. And rest is same as before. It depends on alternate hypothesis. If alternate hypothesis is two-sided, we use a two-tailed test, otherwise we use one-tailed test. Okay. The only difference here is to find Z0, we use sample standard deviation instead of population standard deviation, which is unknown, provided that N is larger. Okay. Next is same case, sigma square unknown, but we use T's test. We use this when N is lesser than 30. Okay. If N is greater than or equal to 30, still we use this Z test. If population distribution is not skewed too much, otherwise we use T test itself. If null hypothesis is this, mu is equal to mu naught, test statistic is this, T is equal to x bar minus mu naught divided by, okay, again in this case it's mu naught, I just wrote mu, divided by S upon root n, and key value is this T naught, x bar minus mu naught divided by S upon root n. Okay. Again, next test depends on alternate hypothesis. If alternate hypothesis H1 is mu is not equal to mu naught, okay, mu less than mu naught, mu greater than mu naught. Now, S is same as this, but we use T distribution instead of Z distribution. And we know what is confidence interval. Now, assume that alpha is a level of significance, then confidence interval is between T alpha by 2 minus T alpha by 2 and T alpha by 2. Let me draw this picture. Minus T alpha by 2, and degree of freedom is n minus 1, T alpha by 2, n minus 1 degree of freedom, n minus 1. This is critical region, and this is acceptance region. And we found this T value, T naught. If T naught is here, we reject null hypothesis. If T naught is between these two numbers, we don't reject null hypothesis. Okay. Again, P value is this area. If T naught is this minus T naught, P value is some of these two areas. We cannot find P values when T distribution is given because we don't have a table for that. So they don't ask in the examination, but we can use some statistical sources to find these P values for T distribution. Okay, similarly, as before, for mu less than mu naught, and critical value is T alpha comma n minus 1. This is critical region, rest is acceptance region. And this is minus, this is critical value. When mu is greater than mu naught, T alpha comma n minus 1. This is a rejection region, and this is acceptance region. Okay, that is if T naught lies here, we reject null hypothesis. If T naught is somewhere here, we don't reject null hypothesis. Similarly, here, if T naught lies here, we reject null hypothesis. If T naught lies somewhere here, we don't reject null hypothesis. Now, finally, testing the hypothesis on proportion. Null hypothesis P is equal to a P naught. An alternate test statistic is Z in this case. We assume that N is larger, again, greater than or equal to 40. Test statistic is Z, which is P cap. Okay, we find test statistic value. Let me call this Z naught. Z naught is equal to, we find sample proportion minus P naught divided by standard deviation of sample distribution of proportion. Okay, we make use of population proportion itself. P naught 1 minus P naught divided by n. I think what I written is correct. Yeah. And rest is same. Alternate hypothesis can be a P not equal to a P naught, P less than P naught, P greater than P naught. If alpha is level of significance, Then acceptance region is Z alpha by 2, Z alpha by 2. This is acceptance region. The rest is rejection region. Now in this case, acceptance region is Z alpha infinity. In this case, acceptance region is minus Z alpha infinity. Acceptance region is minus infinity Z alpha. Okay. That's it. The same as case 1, what we discussed. I didn't say something, I guess. I missed saying something about a level of significance. Level of significance, if you recollect, it's nothing but probability of type 1 error. That is a probability of, okay, I write it here. P is level of significance, sorry, alpha is equal to probability of rejecting null hypothesis H naught when mu is equal to mu naught. This is null hypothesis, right? Null hypothesis. That is, when we reject this null hypothesis, when test statistic value lies in this region, right? And the probability that this happens is nothing but this area. This area is alpha. Thus, we can say that level of significance is same as area of rejection. That is, alpha is equal to area of rejection region. Alpha is not rejection region, it's area of rejection region. Okay, that's it. In the next session, we discuss examples on this one. Now, for now, thank you.